Hello and welcome to another of HORIBA's webinars. Today we have Rien Sprinkhausen from TE Instruments. He's coming to us from the Netherlands, so this is HORIBA's very first international recording. Today Rien is going to be discussing the Explorer Combustion Analyzer. Please begin, Rien.
Okay, well again, good morning, good afternoon for some of you. Here it's good evening. I think Chris, who just returned from Canada, is also listening in, so good evening is I think important as well. So HORIBA Explore the Future, which is not a coincidence. We're going to talk about the Explorer instrument, so that fits very neatly. Our relationship with HORIBA is they are our distributors for the Americas. We have been working with them very closely now for, I would say, running up close to a year, I guess. We have set up demos, organized all sorts of stuff, so the people of HORIBA, the service staff, the salespeople, they're all ready and just as enthusiastic as we are with the products to get it up and running. So we will be talking about a combustion analyzer, the Explorer. Total nitrogen, sulfur and chlorine are the elements we can measure on these systems. So we will do an introduction of combustion analysis in general. We will explain the basic principle of the Explorer combustion unit. We will go into detail about the detection capabilities, especially the lower levels now with the Tier 3 regulation on sulfur. The flexibility of the instrument, besides the instrument being the smallest, or let's say having the smallest bench space in the market, it's also quite flexible in terms of running different samples, whether those are liquids, gases or solids. We will demonstrate that as you in a short video we have compiled for you. And the repeatability, also after exchanging modules during a real life demo, switching from solids to liquids can be very challenging, and we would like to demonstrate that the Explorer has no issues with that whatsoever. Something about what we call the evolution of combustion instruments. I think the first combustion analyzer, which was manufactured in the Netherlands by the company called HORIBA at the time, was the ECS 1000 series, which was a coulometric system based upon a combustion principle, and halogens were measured by coulometric titration. Then that company was acquired in 1996 by Thermo, and a couple of years later there was an introduction of the 3000 series analyzers, capable of also measuring nitrogen and sulfur. Then there was a 4000 unit, which was specialized in running low-level sulfur analysis, ultra-low. In 2009, which you will see on the next time frame, the factory here in the Netherlands was closed, and basically that was where the point where TE Instruments was basically founded, and we started the development of the Explorer series. In the meantime, the product line was moved to Cambridge, where they introduced an iPro system in 2011. And in 2012, Thermo decided no longer to pursue the microelemental analysis combustion units, simply because too much of a niche market and the numbers probably not interesting enough. As for the company where we are located, that's very interesting. So currently we have an install base of the Explorer series of 360 units. So we do have some relevant data and feedback from customer interaction and applications. And as you can see, the company TE Instrument was founded at the end of 2009. 2010, basically that year, was spent in R&D, and all our knowledge of the previous generation instruments was used to come up with the Explorer system, where we took in mind that the ease of use was very important of the unit. The bench space was becoming an issue. We're getting much more, and or let's say many fully automized units on more, let's say, time-filled laboratories. So the unit has to be compact, but also very easy to use and to run analysis with. So in 2011, the first Explorer series was sold into the market, which was a halogen analyzer, and the release of the nitrogen combined sulfur version was 2012 at the Analytica in München. In 2013, there was a gas and LPG automated module introduced to accommodate a full capability for the Explorer systems to be able to run not only liquids but also solids, gases, and LPG, so liquefied gas as well. Last year there was an introduction of a GBS, which is a gas bag sampler for those customers who do not have like pressurized cylinders. So this device simply draws a amount of gas to introduce into the system. So the Explorer is considered a 5th generation combustion elemental instrument. So this is the basic Explorer, the Explorer platform if you want. And a big difference with other instruments in the market is that our boat drive, or let's say semi-automatic syringe drive module, is always a part of the instrument. So if somebody decides either to do solids or liquids, that kind of drive mechanism to accommodate solid introduction or liquid introduction is always a part of the Explorer unit, and therefore the footprint is not increasing because of it. So this unit in basic, as it's presented here, has a capability of being configured as a nitrogen or sulfur only, a combined nitrogen and sulfur unit based upon chemiluminescence for nitrogen and UV fluorescence for sulfur detection. A separate module is the microcoulometric version with the titration cell in front. But all other parts, so sample introduction modules, automated systems, are all interchangeable between the units. They're all the same. So the footprint, as we said, is really small. As far as we've seen, it's the smallest in the market, and especially the width of the unit with 14.2 inches is quite small. Then the sample introduction module. So on this standard platform there is a choice for either a liquid module, which is suited to introduce liquid samples and vaporize them at 420 degrees C following the HCM ruling. The temperature of this liquid module is fully computer controlled. Data can be stored in methods, so it automatically puts the right temperature at the right time. The boat module, which is either for liquids or solids, and especially for liquids over a boiling range of 420 degrees C, is a very easy to exchange module as well. So it's only the piece of glassware basically which is changed. And as you'll see in the video, you will see the ease of exchanging those modules and get you back up and running within a matter of minutes. Then auto sampler options. For the Explorer units, there is an Archie, which is a XYZ auto sampler, which has the ability to be equipped with 2 sample trays, so bringing the total of samples up to 210. And as you see, the tray on the left-hand side, so this tray is equipped with a Peltier element, which makes it capable, so you have a choice, computer-controlled, either heating or cooling the sample. So this is an optional thing for either very light hydrocarbon products or for the heavier ones or the wax, to make sure that they're in a liquefied form before you either inject them into the liquid module or if you inject them into the solids module. Then there is a Newton, which is a solid autosampler, and as you can see, positioning the solid sampler on top of the basic platform again is not increasing your footprint of the unit. There is a carousel which accommodates 20 samples. Those are sample cups which are made out of quartz glass or other materials if that's a preference. And you can see there is one sample tray stacked, and basically this is you're able to go up to 60 samples, so you would have 3 stacked trays on top of each other, accommodating 60 samples as a solid sample. You see the cover here on the front, the little cover. This is what we call the clean cup collection bin. So once a quartz sample cup is introduced into the furnace, the moment it retracts, it can be collected from this collection bin here, which means your sample cups are clean and ready to be used again for the next samples. Then there is a GLS, which is a gas liquid. So the front end is the LPG connection, and the quick connection on the back is the one for gas. It has a touch screen. It can work as a stand-alone device, but it can also be connected to the Explorer using the computer, and then the software program connects with the module and introduces sample loops, either for gas or LPGs. And the four-step principle of the instrument itself. So there is a introduction part where we have a choice to introduce solids, gas or liquids. This is the exchange of the liquid module or the boat module depending on the need and the type of sample. Then there is a furnace, which by default is set at 1000 degrees C. It's a dual zone furnace which comes with a 5-year warranty on the furnace. And the dual zone, it gives you the capability to be quite flexible with temperatures and introduction parts for the boat control. Then there's conditioning, where basically water vapor is removed from the gas and particulate particles are being filtered out before we go to the detection part, where we have again a sulfur detector based on pulse UV fluorescence, either a nitrogen detector based on chemiluminescence, and halogens in general based upon the colorimetric detection technique.
That was the mouse. The mouse is not visible on the screen.
Then total nitrogen by chemiluminescence and total sulfur by UV fluorescence. The RG liquid sampler, startup packages. There is a small compact PC which is being hidden at the screen for your basic configuration if you run nitrogen and sulfur liquids with a boiling range below the 220 degrees C. So this would be your typical configuration. Following the 5453 method, tier 3, and for nitrogen the 4629 method. The liquid sample introduction with the use of the liquid module as it's laid out with the temperature control. We do inject samples typically at a speed of 1 microliter per second, which means that if you choose for a 100 microliter introduction, the sample introduction takes about 100 seconds. The temperature inlet by default is positioned at 500 degrees C, and it's a matrix independent, which means that either if we calibrate it with an isooctane or if we calibrate it with a standard range which is made up in xylene or toluene, the data output is exactly the same. So the area count for standards made up in different matrices is exactly the same. So it's a matrix independent sample introduction. Some typical sample examples for this configuration would be naphthas, fuels in general, high purity solvents, and of course LPG and gas as an example. For the solid boat introduction, this will be your typical configuration. The liquid module in this case is exchanged for the solids module, so boat introduction with boat cooling, which accommodates the next sample to be introduced in a cooled boat introduction system. Software controlled boat program, which can be customized for a specific application or for a specific hydrocarbon, which means there is a choice to introduce the boat quickly, slowly. There can be a pause time at a certain temperature zone to let it sit there for a minute before it moves into the furnace a bit further. So there's always full control over the combustion ability of the instrument. Typical samples, viscous hydrocarbons, plastics like the polyethylenes, and solid organics in any form or matter. And the flexibility and module exchange of the Explorer is some of its key features. I mean, with other furnace tube connections or module introductions, there are all sorts of clamps and all sorts of interlocking to make sure that everything is connected in a gas-tight way. With the Explorer, in the basic design, all clamps and all sorts of mechanical connections were designed out to make it very easy to exchange modules or even to remove a furnace tube and reposition it again without questioning whether everything is gas tight. And this is something what we'd like to demonstrate in the little video what we have. So basically we will do We will show liquid introduction samples at first. Then we take out the liquid module, we change it for a solid introduction module, so that will be both introduction. We will be introducing a couple of pellets. Then we remove that module again and return to liquid introduction. So the liquid module then again is mounted to the unit, heats up, we run samples again. Then we will pull the furnace tube from the unit while it's at 1000 degrees C. We reposition it again, introduce the liquid module again and run similar samples to see what happens with the repeatability and the precision. We will be demonstrating the Explorer with the nitrogen and sulfur capability. We will run liquids, switch to solids, and back to liquids again.
And it's
so
at
in this window, samples are added to the sample list, which we will be running. And you see there is a counter in the upper right-hand screen, which is running, which is showing you the real time. We have speeded it up for you to have the video in a shorter time, where you can see that now liquids is being injected with the XYZ autosampler into the liquid module. And you see now the peaks appearing. So the red one is the sulfur signal and the blue line is the nitrogen signal. So we're running simultaneous analysis of nitrogen and sulfur.
It's at this time, if you can't see the upper corner of your screen, you might want to hit that little orange box with the white arrow, and then you'll be able to see a larger portion of the screen.
Let me jump back quickly. So this is the point where we give a comment to the instrument to retract the liquids module from the furnace. You can see by the orange glow that the furnace is at 1000 degrees C, but nevertheless it's not that hard to get the liquid module from the system. Then we have to remove a plug and attach the oxygen line to accommodate the solids module. And the solid module is positioned. It's connected to the furnace tube simply by rotating it clockwise. The software is recognizing this module and now automatically it gets a signal to close the shutter to make it a gas-tight environment. Again, connecting the argon line, connecting the oxygen line. In the meanwhile, we prepare a sample cup with a couple of PETS granulates, which we will then introduce with the boat. So again, in the software, we will add samples to our sample queue. We key in what type of sample we're running. We connect it to the right method. We click on the start button and then you see the shutter opening up for us to be able to introduce the sample cup into the combustion system. So now the sample cup is introduced. The shutter will close automatically, making sure that everything is gas tight. And then the boat introduction into the furnace at 1000 degrees C will take place. At that point you also see the signal going up. Again, the blue line is the nitrogen compound and the red line is the sulfur compound of the sample. After combustion, the boat retracts the sample cup from the unit. The sample cup is being disposed into the cup collection bin for reuse again. We disconnect our lines, our gas lines. We remove the solids module, put the plug back in there. We will get the liquid module, position it, make a connection with the argon and oxygen, and argon can also be substituted by helium. The software recognizes that we switch from solids to liquids. It will do the appropriate settings. We check the guidance if the quartz glass fits nicely into the furnace again, and we're up and running for liquid samples again. So we add samples to it. The RG sampler next picks up the sample from the file tray and then goes through the injection port to deliver the sample at a speed of 1 microliter a second. And again, we make a couple of replicates to be able to show you the RSD. And you can see we already switched from liquids to solids and back to liquids again within 45 minutes. If you look into the red circles, typically you can see what the average sulfur signal is, and you can also see that the RSD for sulfur is 1.67 and for the nitrogen is 0.43 RSD at a level of, for the sulfur, around 7.4 and for the nitrogen 68 roughly. So the software also has the ability to do signal overlay. So if you run triplicates, you can make a selection of those 3 graphs, overlaying them to see if the shape, form, speed of introduction is exactly the same, which should result into a similar area count. But then the events where we have to either remove the furnace tube for inspection or have to replace it simply because it had been operational for a long time and it needs to be checked during the maintenance period. So 1 Allen key is sufficient to release the 2 Allen screws, and as you can see the furnace tube is still glowing hot at 1000 degrees C and we can pull it from the furnace. The same goes for reposition it again. So once you get it into position, push back the furnace tube, mount the 2 Allen screws, connect the liquid module again, introduce it to the unit, gases are stabilized, and we can be adding samples to the sample queue again and run those. And as you can see, in under 30 seconds we pull the tube, put it back in again. Next we will be running, after this exchange of modules and after pulling the furnace tube, we run a 1 ppm sample. And this is a simultaneous analysis of 1 ppm sulfur and 1 ppm nitrogen. Again, we run a couple of replicates, in this case a triplicate, and we will checking whether we get the appropriate number and with the appropriate accommodating RSDs to it. As you can see, we have thrown out the first result, because you can tell by the shape of the peak of the nitrogen that the first one picked up some impurities from the laboratory environment, either from the air or being exposed to the laboratory table. So typically if we switch from a higher to a lower result after exchange of modules, the first one is excluded from the calculation, giving us the result of 107 on sulfur and 105 on the nitrogen. Okay, now we continue with the presentation again. So we've seen the flexibility, and the video and the YouTube link, as you can see, are present. So you can see this in real time running, because with the webinar tool you'll see the imaging is not that smooth, but you can repeat it and look at those details which we discussed about. So summarizing the video, liquid introduction, the exchange to the solid introduction by both took us 80 seconds. To return to liquid introduction again, so where the liquid sample is evaporated at a controlled temperature, 70 seconds. To pull the furnace tube from the unit, let it cool down, put it back in again, takes 60 seconds, and this without any clamp to make a gas-tight connection. And then we return to the liquids introduction and we run a sample at a 1 ppm level for both sulfur and nitrogen. So for the liquid introduction we had a diesel sample with a sulfur concentration of 7.58 ppm with an RSD of 1.2. We exchanged to solids. We run PET samples, total sulfur concentration 13.9 ppm. Then we exchanged modules again. We reintroduced the liquids module. We run sulfur at a concentration of 7.28 ppm with an RSD of 1.7%. We pulled the furnace tube from the unit and we introduced the liquids module again, got a stable baseline signal again, run 1 ppm sample sulfur, which came out as a 1.08 with an RSD of 1.3%. So for the total nitrogen, total sulfur UV, particularly for sulfur, the 5453 method, you've seen that this unit has the ability, even exchanging modules, and still get a good precision and repeatability, what tier 3 analysis is looking for. So allowable on the 1 ppm, statistically the 17.9%. During the live test, after all those exchanged modules, 1.3%. At the 7 ppm range, where it's admissible to have an 11% RSD, we had for one sample 1.17% RSD, and for the other sample 1.67% after the module swap. So this proves the flexibility of the instrument, the sample range you have, where you don't have to collect, let's say, only liquid samples, but you have the ability to, after lunch, simply change to solids, run solids. In the afternoon, put it back to liquids again and let it run liquid samples overnight. So now you really have a choice in combustion analysis, and even if your sample demand in the beginning is only focused on liquids, you see that with a very simple piece of glassware you exchange the system's ability to run solid samples in a matter of minutes. So that's basically the Explorer, a very universal, compact instrument doing the job and following the tier 3 regulation to the letter. So demos, HORIBA is equipped to invite you at various demo sites, and you can bring some of your samples along, or you can make an appointment with them, and they're very happy to accommodate a demo at your facility.
You have been listening to Rien Sprinkhausen from TE Technologies. Thank you for your time.